All right, so we have a theorem to add into our notes. This one is called the perpendicular bisector theorem. So we're going to be talking about perpendicular, right angles are formed. Bisector, we're cutting something in half. So let's see what this theorem is. We've got our triangle ABC, and then we have this point D on this bottom part of our triangle. So if AB is congruent to BC, well, right there we have an isosceles triangle, and the measure of angle ABD. So I'm going to go ahead and connect segment BD, because now we're saying that the measure of angle ABD is equal to the measure of angle CBD. Then we can say that BD is perpendicular to AC. So if it's perpendicular, that means that we have formed right angles on either side. And AD is congruent to DC. So here's AD is congruent to DC. All right. So that would make BD the perpendicular bisector, by the way. So we started out with AB being congruent to BC, and then we drew in segment BD. We had these congruent angles up here. If that's true, then that means that BD is perpendicular to AC and that those segments are congruent. All right, so the converse of our perpendicular bisector theorem just flips those. If BD is perpendicular to AC, so BD is perpendicular to AC, giving us the right angle. So that's one thing we're given at the start. And AD is congruent to DC. AD is congruent to DC. Then we can conclude that AB is congruent to BC. By the way, if BD is perpendicular to AC and we get these congruent segments, that makes BD a perpendicular bisector. We can then go on to conclude that AB is congruent to BC and the measure of angle ABD is congruent to the measure of angle CBD. Okay, now let's put that knowledge to use with this real world example. A prefabricated house is delivered to a foundation in two symmetric halves that are assembled on site. Along the planned route of the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? Explain. Okay, so what we're wondering is this house going to fit underneath a 17-foot, a bridge that has a clearance of 17 feet? So if we look at the house, we know that this is 28 feet. We know from the bottom of the house to the bottom of the roof is 10 feet, but we don't know how tall the roof, we've got 10 feet here, and how much more does the roof add on if that's going to clear the 17 feet? So let's go ahead and recreate that roof. We're going to redraw our picture so we could just focus on this part. Let's go ahead and just label. Oh, it is labeled. Just kidding. They told us this is point A, point B, point C. So I want to point out that they've got this vertical line because that is where this prefabricated house is cut in half. It gets put together along this seam, and we can see that these angles are marked as congruent. So we're going to draw in that middle part, and we'll just go ahead and call this point D down here and get those congruent angles drawn in. So this seam right here is vertical, this is horizontal, so that is going to form a 90-degree angle right there. So what we have is BD with those 90 degrees makes it perpendicular to AC, and we have congruent angles up here. So BD is the perpendicular bisector. of segment AC. All right, so we know that segment AC is 28 feet because down here is 28 feet, so up here it'll be 28 feet. If BD is the perpendicular bisector, it did cut that in half. So we know that this is 14 feet and this is 14 feet. We also have some additional measurements in the picture. This roof line, the slanted roof line on either side is 16 feet. And what we're trying to figure out is, I guess I'll just use an H for height. What's the height of this part of our roof? That's from here to here. You guys remember that one little thing called the Pythagorean Theorem? Pythagorean Theorem is a squared plus b squared equals c squared. You can use this to find missing sides of right triangles. We have a right triangle because of the perpendicular bisector. And as long as you plug in the hypotenuse for your c value, that is the side opposite your 90-degree angle, then we can use Pythagorean theorem to find our missing side. So a squared plus b squared, 14 squared plus height squared, h squared equals, the hypotenuse is this longest side opposite our 90 degrees, so 16 squared. So to simplify, let's just square everything. 14 squared is 196 plus our height squared, and 16 squared is 256. We want to solve for our height, so we will subtract 196 from both sides. Our height squared is equal to 60. To undo that squaring operation, we will square root both sides. And if you square root 60, it's equal to about 7.7. I'm doing some rounding. Maybe I'll use a squiggly for about 7.7. So let's go back to our figure. What we just figured out is from here to here is 7.7 feet. We know that from here down is 10 feet. So the total height that this prefabricated home has is 17.7 feet. That's for the house. The bridge has a clearance of 17 feet. Will the house fit underneath it? No, it will not. So I think the question was, should the trucker plan a different route? Yeah, they should. These are the things they have to think about. How tall is the thing that they're carrying or trailing or whatever? Will it fit underneath all the bridges that they have to go underneath? And in this case, nope, they need to find a new route.